Welcome back, friends. Let us continue with class 10 mathematics, chapter 12. Let's start from where we left. Exercise 12.2, the third video on exercise 12.2. Let's do question number 8. It states a horse is tied to a peg. Peg means maybe a stand or a post, in other words, at one corner of a square-shaped grass field of side 15 meter by means of a 5 meter long rope. That means we have a square field and maybe the horse is tied at this end of the square field by a 5 meter long rope, and this square is of dimensions 15 meter. Peg means, in other words, again maybe a stand or a post where one end of the rope is tied, on the other end we have the horse. Now the first thing that comes to our mind that it is a square field tells us that the vertex angles of a square are always 90 degree each. So that's one thing we should always remember before we start the problem. Now the question is, find the area of that part of the field in which the horse can graze, the maximum area. That means this horse, if we go for the maximum length of the rope, that is 5 meter, it can maybe graze a section of this portion, maximum area. It can graze up to this portion. That is, it will create an arc, a circular arc, which ultimately will create a sector for us. That is because this length will also be 5 meter, because the length of the rope we are taking the maximum area that the horse can graze. Of course, that's why the horse can graze here in all these places. So we are looking for the maximum area. So now in that case, what do we have is we have a sector that is being formed where the central angle is also already given, actually, since it is a square field, and the length of the rope depicts the radius of the sector. So let's do the first part, that is, since the field is square shaped, the vertex angles will be 90 degree each. Length of rope is 5 meter, which can be taken as the radius. So the area which the horse can graze will result in a sector with central angle, the area or the region which the horse can graze. We can say the maximum region which the horse can graze, where the horse can graze, will result in a sector with central angle theta as 90 degree. So let's find out. Therefore, area which the horse can graze will be area of the sector, that is pi r square into theta by 360. That's how I told you to remember. Now in the note, there's one given question. In the question, one note is given, use pi as 3.14. So that will be 3.14 into radius is 5 meter whole square into theta 90 out of 360. So 91, 94s are 360. So 3.14 into 5 square is 25 meters square divided by 4. We can divide this by 2, 1.57. So that is 1.57 into 25 meter square divided by 2. So that will be, I will not multiply here. I believe that you will be able to do the multiplications. Rather, I will just do the division. That is 39.25 divided by 2. 2 ones are 2. 1 left, 9 comes down, 2 9s are 18. Decimal starts, 1 left, 2 2 6 are 12. No remainder. 5 comes, 2 2s are 4, 1 left. Since it is after decimal, 0 will come on its own. 2 5s are 10, so that will be 19.625 meter square. And the second part of the question that states, also find the increase in the grazing area if the rope were 10 meter long instead of 5 meter. That means if the rope is 10 meters long. They're telling us to find out here also the central angle will remain the same, 90 degree. They're telling us, now we can clearly see from the figure that if the rope is increased to 10 meter, then this is the increase in area, no, the extra area that it can graze, and that is what the question is telling us to find out. That is the increase in area. Sometimes we just confuse it with the total area that it can graze, that is this complete area. It's not the case. We are just told to find out the increase in area, that is only this portion. Now for that, what we will do is I'll just draw another sector here, that is the first one of length 5 meter. Now we are supposed to find out for the increase in area of 10 meter, this portion. So for that, first we will find out the total area it can graze when its length of the rope will be 10 meter. So area it can graze when length of rope is 10 meter will be pi r square into theta by 360. That will be again 3.14 into r 10 meter whole square into 90 by 360. Again 91, 94s are 2 2s are 4, 1.57. That's 1.57 into 100 divided by 2 meters square. 2 1s are 2, 2 50s are 100. So 1.57 into 50 meters square. So that will be 1.57 into 5. 5 is 35, 3 left, 25, 28, 2 left, 7, 1 0. That will be 2 decimals. That's 78.50 meter square. So now the increase in area will be 78.50 meters square minus the area which it could graze when the length of the rope was 19.625 meter square. That's how we will find out, isn't it? Because if you want only this region, then it will be this complete region minus the smaller region. That will give us this particular, the increase in area. I hope you have understood the concept of increase in area, because if you have a number 5, it is increased to 7, then what is the increase? It is 7 minus 5, that is increase is 2. So we are going to use that concept. So that will be 78.50 minus 19.625. So we'll extend 1 0, subtraction 10, carry over 5. So carry over 10, 9 left, 7. So here 14 left, carry over 6, 14, 8. So here again 17 left because it is carried over, so 9. So that will be 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So here 6 left, so 1, 5. So increase in area is 58.875 meter square. Next up, let's quickly do question number 11. That is, a car has 2 wipers which do not overlap. Each wiper has a blade. I hope all of you have seen a car wiper. A blade of length 25 centimeter sweeping through an angle of 115 degree. Find the total area cleaned at each sweep of the blades. So the question is clear. Let us imagine a car wiper. That is, for example, if this is the screen of the car, then we have seen that a car wiper is it's fixed something somewhere like this, and the other wiper is at the other end. So now the question is, each of these car wipers will sweep an area in such a way that they do not overlap. So this will be the area swept by this wiper, wiper 1. This will be the area swept by the second wiper. Now each wiper makes an angle of 115 degree. Each wiper makes an angle of 115 degree, and each wiper length is 25 meter. 25, I hope I'm correct, 25 centimeters, sorry, 25 centimeter. Now they are telling us simply to find out the area, total area swept. So the concept is very simple. So what we will do here is, each wiper will sweep a region, making a, I'll write in simple English, making a sector of a circle with central angle theta as 115 degree, and radius, that is length of each wiper, will be 25 centimeter. So total area cleaned will be equal to area swept by both wipers. So now, since both the dimensions are same for both the wipers, no, radius 25, here also radius 25, angle 115, here also angle 115, so I'll just multiply it by 2, that is pi r square into theta by 360, that is 2 times 2 represents here twice the 2 wipers instead of doing separately. That is 22 by 7 into radius 25 centimeter whole square into theta 115 divided by 360. So let's expand 22 by 7 into 25 into 25 into 115 by 360 degrees. So that will be, which is 5 5s are 25, 5 7s are 35, 72, 2 1s are 2, 2 36 are 72, continuing, 2 11s are 22, 2 18. So that will be 11 into 25 into 5 into 115 divided by 7 into 18. So this product will be 11 555 into 25 into 115 divided by 18 into 7, 7 8 are 56, 5 left, so 7, 126, and this product will be 158125 divided by 126 centimeter square. So this is the solution. This will be the total area swept by the 2 wipers combined. So I hope you have liked this video. If you have liked this video, do comment, and if there are any other questions which you would like us to solve, please do comment below so that we can do the needful for all of you.